Alright guys, here we have another word problem dealing with radical functions and transformations. So let's go ahead and read the problem and then we'll go over how we're going to set it up. And again, I've kept our little guide over here, or cheat sheet for transforming radical functions. Alright, so let's go ahead and read the problem. It says f of x equals the square root of 64 times x can be used to approximate the downward velocity of an object in feet per second after bouncing x feet in height. So this following equation right here can be used on Earth to approximate the downward velocity of an object after bouncing x feet in height. Alright, and we'll draw a diagram of what this looks like after. Alright, then it says to apply this function to the moon, we must horizontally stretch it by a factor of 25/4. Okay. What is the downward velocity of a landing craft at the end of a bounce 75 feet in height? Okay, so essentially this is what they want to know here. So let's draw this out. So you have a landing craft that bounces 75 feet in height. So here it is right here. It bounces 75 feet in height. Okay, now they want to know that downward velocity, okay, that's going to occur on its way back down. What is going to be this velocity, okay, on its way down? Okay, and again, this is what the equation, okay, can approximate here. However, this is for Earth, right? We need to do it for the moon, and in order to do that, we have to horizontally stretch it by a factor of 25/4. Okay? So remember, it's going to be a horizontal stretch, okay? If your B value, which in this case, this is going to be our B value, right? I'm looking at this part right here, horizontal stretch of compression. If it's going to be a horizontal stretch, our B value has to be greater than 1, okay? If it's a horizontal compression, it will be between 0 and 1. Well, 25/4, right? We do that in our calculator real quick. So 25 divided by 4, that's going to be 6.25. So that's greater than 1, right? Hence why it's going to be a horizontal stretch, okay? All right, so what we need to do is take this B value and plug it in. So essentially what we're going to have here is we're going to put a 1/B here. So let's go ahead and write this out. So for the moon, and let's do it in another color, we'll have f of x. Well, actually, let's call it g of x since we're making a new function, right? So g of x equals, and we'll have the square root, and you're just going to follow your model here, so 1/b. So I'm going to essentially do here 1/25 all over 4, right? And then I'm going to do times, we're keeping everything the same here, times 64, let's do 64x. Okay? So what needs to happen here, right? We have 1 divided by 25/4. Okay, when we do this out, this is really going to become 4/25, right? And if you're having trouble visualizing that, just remember essentially what we have here, right? We have 1 divided by 25/4, right? And we know that this is really over 1. So use your rules for dividing fractions, keep, change, flip. So essentially we have 1/1 times 4/25. So essentially this becomes 4/25. Okay? So let's go ahead and rewrite this now. So this whole part right here will be 4/25. Okay, and I'm going to erase this guy. So again, we'll have g of x equals, we determined that part's going to be 4/25, 4/25, and then times 64x. Okay, let's do this out now. So 64 times 4, 64 times 4, we get 256. So we'll have g of x equals the square root of 256 all over 25, and this will be x. Okay, so all we have to do here is plug in our height in for x here, so it's going to be 75. We're going to plug a 75 in here, so, and we're just going to do this out. So I'm going to do everything within the radical, and then I'll take the square root at the end. So I'm going to do 75, right, because I'm going to plug it in. So 75 times 256 divided by 25, and then I'm going to take the square root of this answer, and we get 27.7. So for this, we get 27.7. And again, this is going to be in feet per second. So 27, oops, get another color. That marker's dying. So 27.7, and this will be feet per second. Okay, and this is going to be your final answer. So you can expect a downward velocity of a landing craft of 27.7 feet per second at the end of a bounce that was 75 feet in height. Okay, so this is going to be your final answer here, and that is it.